Hi, everyone. This is the Hungry Math Professor here, and welcome to my channel. And today we're going to be discussing this book that I'm not even sure why I'm showing you. There's not much to see because I think there used to be a jacket, um, and you can see that there's all these coffee stains. It's a well-worn book, but this is called the Infinite Book by John Barrow. Um, I really enjoyed this book. It was written in 2005, and the secondary title is A Short Guide to the Boundless, Timeless, and Endless. The book is about infinity, and you can take that in various different directions. And the book does kind of go into a lot of the directions you might expect. So he talks about Zeno's paradoxes. He talks about Hilbert's Hotel and George Cantor and the discovery of different sizes of infinity. So I did a video showing you that there is at least countable and uncountable infinities, but it turns out that there are many different sizes of uncountable infinities as well. There's a whole hierarchy of them. So he goes through that discussion, and then he talks about things like, is the universe infinite? And he goes in various different directions in the later chapters. But I really enjoyed this book. I bought this book probably right around when it came out when I was in high school. So I graduated high school in 2006. And, I was a kid. I really enjoyed my math classes. I enjoyed my science classes. I was really curious and enjoyed almost all my classes. But I think, in math class, I was more curious than the class provided, I would say. And the way we teach math, I mean, I haven't been in high school a long time, so I don't know how much things have changed, but generally the way we teach math was not the most inspiring. Um, and I don't really want to blame anyone for that. I think it's difficult to teach everybody math, and there's lots of things that get in the way of making it interesting and exciting at times. So I won't don't go there right now, but sometimes we need something to just be inspiring to elicit our passions, and factoring polynomials is not really generally going to do that. So for me, this book was so important at that point in my life to just excite me about other, like, where, draw some awe and wonder about where mathematics goes, and how expansive it is and large, and how unintuitive it can be at times, and that's exciting, right? I remember reading this actually in the lunchroom by myself, and probably if you looked at me, I'm just by myself in the lunchroom. What is this kid doing reading this book? But inside my head, there's like fireworks going off because the book is just exciting me on a level that you can't see on my face. And so I really recommend this book. And I also just recommend, if you have someone in your life that is doing well in math, maybe they're a teenager or in college or something, and you want to try to expand their view of what mathematics can be, this is a good book just to do that. You're going to learn a lot of different things. The goal here is not necessarily like rigorous learning mathematics. You can do that in the classroom, but sometimes we just need to be inspired and forget about all, learning all the little details. Sometimes we just need that sort of poetic exploration of something, and just to feed our curiosity, and then we can go, and I went to grad school, I went to college, studied math, and then went to grad school and studied math. So you can do that later, but sometimes you just need to be inspired, you just need to be excited, because we're human beings, right? So let me read a quote from the preface just to give you a little bit of idea of what's going on here. um, so he says, this is a book about the biggest subject of all. It's the ultimate traveler's guide to everything that could be, the rough and the smooth guide to infinity. Infinity has haunted human minds for thousands of years. It challenges theologians and scientists alike to understand it, cut it down to size, find out if it comes in different shapes and sizes, and decide whether we want to outlaw or welcome it into our human descriptions of the universe. Is it part of the problem or part of the solution? So skipping forward a little bit. Mathematicians have also had to face up to the reality of infinity. The issue was a big one of the biggest that mathematicians have ever faced. Just 70 years ago, mathematics faced a civil war over the meaning of infinities, leaving many a casualty and much bitterness. Some wished to outlaw infinities from mathematics and redefine its boundaries to exclude all treatments of infinities as real things. Journals were closed down and mathematicians ostracized because of their attempts to exclude infinities from mathematics. So yeah, there's this really exciting, exciting, but also raucous time in the history of mathematics, where after George Cantor gives his description of all these different sides of infinity, and after people notice all these paradoxes with naive set theory and naive um, yeah, that there's this question of like, what do we do about this, right? And so there's some people who are still finitists, who say that only the finite things are real, and that's all we should be studying in mathematics, right? And this is a very safe position. It's a very defensible position in the sense of, if you're willing to be that conservative, then you're on very solid ground if you stick to just finite things, right? So that's the plus side, but it's so strictly conservative that we worry that, like, hey, but you're leaving a lot of things out. There's lots of pretty stuff, lots of beautiful mathematics that we should explore that's not finite. Are we should we really chop our world down to that size, just because we're a little worried? But there are still, I've never met a finitist myself, but apparently there's still finitists out there. And it's interesting to think about where their point of view is. But then also, intuitionism famously by Brouwer is sort of this middle road. And I won't explain all of intuitionism, but one thing you can think is that he accepts infinities as long as you can construct them in some way. As long as you can give a procedure to construct them, then we can work with that infinity. But just like these abstract infinities that we just claim exist or prove exist logically, but cannot construct, we should remain skeptical, or we should just not work with those things. So again, it's being conservative in the sense that we're going to cut down the size of what we're willing to work with. But he's not as conservative as finitism. But the thing is, in math right now, we've blown way past this. This is not a question that we're asking anymore. Mathematicians have, including myself, have just accepted infinity, wholesale into our our study. I love it. I mean, it's one of my favorite things to introduce to students because there's so many sort of unintuitive things and surprises, and that's like the most fun as a teacher, when I can surprise you a little bit with some unintuitive results in mathematics. So I love, the infinite. I think it's really beautiful, but there are still some difficult philosophical questions about what these infinities mean, and are we on such solid ground philosophically when we work with these things. So it's interesting that even in mathematics there are these questions that are not resolved or not understood philosophically. So please check out this book. Maybe you have someone in your life that you think would really benefit from this. You want to buy it for them. Let me know what you think. Like, comment, and subscribe, and I hope to see you at another video.